Hello everyone, myself Professor Kunalsinh Kathia from Mechanical Engineering Department. Today I will explain you the topic geometric transformations, which is the part of computer-aided design, and we will take an example of the scaling, right? So in the basic, if I tell you that what is the transformations, then these are the methodologies which are required to draw any kind of 2D figures on the screen, like in AutoCAD, Kathia or SolidWorks. Whenever you are drawing something on the screen, it needs or it requires some kind of coordinates, and to perform that you need to go on these equations. If you want to see and want to understand what this transformation is in detail, you can see my another video which is specially on geometric transformations with the example of rotation and translation. You can find it out in YouTube, that the special example of rotation and translation, which is my previous video. In this video I'll go through very fast manner because I am explaining those things in very detail in that video. So here I'll give you just a glance of that. So translation means to move any element from one place to another. So here this triangle is getting moved from one place to another. Another operation is rotation. So to rotate this triangle at 90 degree. So that is the another operation. Scaling means to half that thing. So 1 gem 2, this is 1 gem 1, right? So it can be a 2 gem 2 also. Okay, that doesn't matter that it should be a half. Reflection, okay, so that is the mirroring image of the element, so that is called the reflection operation. Then shear, so if you try to move this edge at upward in y direction, that it will get a shear. Okay, so basic rule for composite transformation that needs to be understood. So here any numerical you perform, you need to perform these 4 steps. First step, translation. Okay, so move your element from one place to another place, where at origin. Okay, now perform the operation. So you can here scale, rotate, or whatever you want to do, you can do here at origin. Then do a rotation. So if rotation is required, you rotate it and then bring it back, that is inverse translation. So step 1, bring to the origin, perform the operation, rotate it, bring it back. So these 4 steps in sequence you need to perform, right? These equations are in methodology I have shown you here. P is original point, translation matrix, rotation matrix, and this is the inverse translation matrix. You need to pause this video and you can note down in the notebook. This is the standard equations. Okay, now example says that a triangle ABC having A, B and C points are here, and we need to scale it, right? You need to scale it by a factor of 0.5 about a point of X, 0, 50 and 40. Okay, so they are telling that there is a triangle and this triangle needs to be the halved. 0.5 of scaling should be there, and we have to find these points, right? So let's first what we'll do with the given data. The given data is A, B and C, which is A is 30 and 20, B is 90, 20 and C is 30 and 80, which is given here. Now scale about the point X, 50 and 40. So X, 50 and 40, about that I have to do a scaling. And how much scaling needs to be done? 0.5. So let's start that. Now they are mentioning that the scale by factor of 0.5, but they are not mentioning that it should be in X or Y. So we'll consider it for both. So you can see that we will consider the scale factor in Sx and Sy is equal to 0.5. So first translation, second scale, and then inverse translation. Okay, because there is no rotation. So standard rule is translation to the origin, then scale to 0.5 and then bring back. Okay, let's do it. Translation. So translation is of the original points T, scaling inverse. So now the original points given were there 30, 20, 90, 20, 30, 80. So this matrix is 30, 20, 90, 20, 30, 80. Okay, so those values are replaced and 1, 1, 1 is here. Another next one, is the scaling matrix. Scaling matrix, you can notice all the adjacent should be as 1 and 0. Now this is not a scaling matrix, this is translation matrix. So now they are asking a translation about the point C, right? When there is one point which is given here, 50 and 40. So this 50 is tx and this 40 is ty for me. So I am replacing those values in the translation matrix, minus 50 minus 40, right? Because we want to bring it at origin, so that's why I am putting negative signs here. Then next, scale matrix, this one, scaling. So scale matrix, they are asking about 0.5 of scale, so put 0.5 here as a x, 0.5 for y, and 1 is the standard value. And next again, inverse translation. So inverse translation means the inverse of this matrix. So I will do inverse, means that I will just remove the negative sign from here. So negative 50 will be positive and negative 40 will be the positive 40. Okay, so now solving the equation, simplifying the equation. So first I will focus this one. I will start from end. So this two matrix will get solved in this way. So if I'll solve, then I get as a answer at this, and these two are just derived at downward. Now next step, I will multiply by this matrix, these last two matrices, and as an answer I am getting this here. This is 0.5, 0, 0, 0.5 and 20, 25, 20 and 1, right? So this matrix is still there. Now at the final stage, what I have to do, I have to multiply this matrix with this one. So after multiplying, I will reach to my final answer. So after multiplying this matrix with this in this manner, okay, you can see another videos that how to multiply the 3 cross 3 matrix, and you can learn that how I have multiplied this matrix. Once I suggest you do practice on the pen and paper, then you can do it. So the final answer is coming that delta A dash, B dash and C dash will be the 40, 30, A dash, B dash 70, 30 and C dash 40, 60. So I have listed down that after doing a scaling of 0.5, the A dash will be a 40 and 30, B dash will be the 70 and 30, this is here, and C dash will be the 40 and 60, 40 and 60. So this was the final answer. Just to revise you what we have done today, they asked to scale down the triangle at 0.5. So first we have translated our triangle, okay, so at origin, then 0.5 and there. The standard equation, original triangle, translation matrix, scaling matrix, inverse translation, okay, and then I have solved this. So this will be the final answer. So till that, now this much is okay. In next topic we will take another session. Till that, goodbye.